Hello, today we will be going over the last section of Chapter 7. And so to begin with, continuing our discussion on operant conditioning, primary reinforcers satisfy our biological needs such as food and protection from harm, whereas secondary reinforcers are classically conditioned to have meaning. And previously, when discussing classical conditioning, I talked about bills of money, which after being paired with material objects such as buying clothes or even a new car, money is associated with a primary reinforcer of keeping us warm for clothes and providing us the opportunity to get to work to earn more money or to the store to get more food, as in purchasing a new car. And so these secondary reinforcers are classically conditioned to be associated with primary reinforcers that satisfy these biological needs. So here we have the over-justification effect, where the rewards for engaging in a behavior may be undermined by the satisfaction we get from performing the behavior. So for example, you guys are good, you are all good students because you checked D12. So say that I wanted to reinforce your behavior of being good students. And so I told you that each time you logged onto D12, I would give you 10 extra credit bonus points. So you would probably start checking D12 a lot more often than you already are, thereby increasing good behavior. But you probably wouldn't have much incentive to come to class, take the quizzes, study for the exam, etc. You would become less good students, doing less good behavior that good students engage in, and learning would not be as effective because you're gaining all of these extra credit points outside of class. So lastly, just like in classical conditioning, operant conditioning is subject to extinction. And with operant conditioning, if reinforcement stops long enough, the behavior may also stop. So for example, if I stop handing candy out for every student that answers a question in class, the students would be less likely to answer questions in class because you're not actively being reinforced with candy. And so here we have over-justification effect and extinction. And so that really wraps up talking about those principles of operant conditioning. So now we move on to discussing schedules of reinforcement. So each of these schedules of reinforcement describe at what time the reinforcement is applied. So similar to the 4 operant conditions, when describing schedules of reinforcement, there are 2 parts to each description. So is the example describing a fixed or variable schedule, and is it an interval or ratio? And the first schedule that we'll discuss is fixed interval schedule. And in the fixed interval schedule, there are fixed time periods where you are reinforced when choosing the appropriate response. So for example, you receive your writing assignments 2 weeks after turning them in, not before and not after. There are 1, fixed times when you receive your graded assignments that you can expect a grade, and secondly, you receive your graded assignment in an interval of 2 weeks of turning them in. And so this has to do with our writing assignments. I have exams up there, and it's similar to writing assignments. The next is variable interval schedule, which involves being reinforced at a variable, or as I like to think of it, as random. So the quizzes you take in class are on a variable or random schedule. So you don't know when they're going to happen, but there's an average time that occurs between the last time that you took it and the next time. And the next one is a fixed ratio schedule, and this involves being reinforced following a specific or fixed number of responses that have been made. So for example, when you buy 10 cups of coffee, you get the 11th cup of coffee free. And this is my Starbucks example. So after a specific number of responses have been made, the 10 cups of coffee, then you're reinforced with that 11th cup of coffee. So it's a fixed ratio. You have to have so many before you are reinforced, and it is always a fixed number. So you have to buy so many cups of coffee which is a ratio, and the fixed number is 10. So here we see variable ratio. And the variable ratio schedule involves reinforcement following a variable or a random number of responses. And with this, an example of variable ratio schedule includes casinos, and specifically slot machines. So slot machines are run using a variable ratio schedule where patrons are reinforced with money or free spins, free play after a random number of spins. So when Grandma says that you have to spin big to win big, there is some truth to that, because the more money you spend, the higher the likelihood that you'll be reinforced randomly. So again, variable means random, and ratio is you will be reinforced after a set number of responses. And so continuing on with that variable ratio schedule, variable ratio schedules of reinforcement produce slightly higher response rates than, say, fixed ratio schedules, because we never know when that next reinforcement will appear. And so this is related to that intermittent reinforcement, where you are intermittently reinforced when you're playing, say, the slot machine. So you're reinforced the first time you put a quarter in and you get 2 free plays, and then variable, which means random. So randomly they pick that you'll be reinforced on the 8th time and the 12th time and the 13th time, and then after that you aren't reinforced until the 100th time. Interestingly, this helps to explain some of gambling addictions and why it is so hard or so much more resisted to extinction. So if I just put another $20, I'll win that jackpot. That may be some type of cognitive process that goes on with these gambling addictions. So variable ratios are harder to extinguish because you do not know when you'll be reinforced for your behavior. In the next slide, that what we talk about are some more demonstrations of operant conditioning at work, which involve shaping and superstitions. And so here we see our cat using the toilet. And shaping, such as teaching a cat to use the toilet, is achieved through successive approximations. And this is where we positively reinforce our cat till we achieve this final behavior of him using the toilet. So successive approximations look like giving him a treat every time he walks by the bathroom door. Then we move on to giving him treats when he steps into the bathroom. Then we move on to giving him a treat every time he goes near the toilet, when he sits on the toilet, and so on. So most of our behaviors as humans are actually the result of shaping, interestingly enough. The next demonstration of operant conditioning at work is superstitious behavior. So if you played basketball, or you do play basketball, and you have this pair of socks that you believe are they bring you good luck, this is an example of superstitious behavior. So operant conditioning actually can help to explain why we engage in superstitious behavior. So superstitious behavior is accidentally reinforced, so that one time when you started a basketball game and you made the winning basket, you may just start to develop the superstition. And so again, with superstitious behavior, it's accidentally reinforced, or just reinforced one time, and then because of that, we're operantly conditioned to think that these socks are going to bring me good luck, and I'm going to be the all-star on the basketball team. And so oftentimes we see these superstitions in sports. So when we're talking about operant conditioning on a deeper level, the chapter discusses cognitive elements of operant conditioning. So Edward Chase Tolman was one of the strongest advocates of the cognitive approach to operant learning, where he researched the organism's ability to establish this means in relationship. So similar to the Rescorla-Wagner model, Tolman's means in relationships suggested that organisms must learn to expect the response upon realization of the stimulus. So he further focused his research on what happens in the organism's mind rather than on the stimulus-response connection. So evidence that he believed supported his views on a means in relationship include this latent learning. And latent learning is where something is learned but not manifested or acted on until sometime in the future. And latent learning and cognitive maps suggest that operant conditioning involves more than an animal's response to a stimulus, that there's really a cognitive component to operant conditioning, even in rats. And continuing on with this discussion of neural elements or the brain's connection to this operant conditioning, the first hint of how specific brain structures might contribute to the process of reinforcement came from the discovery of pleasure centers of the brain. So James Olds and researchers inserted tiny electrodes into different parts of the brain of rats and allowed the animals to control electrical stimulation of its brain by pressing a bar. And they discovered that some brain areas, particularly those in the limbic system, produce intensely positive experiences for the rats. As a result, the rats would press a bar repeatedly to stimulate these brain structures, so much so that they would ignore food, water, and other life-sustaining necessities for hours on end, simply just to receive this stimulation directly to this area of the brain. And following this discovery, these parts of the brain were named the pleasure centers. And since then, researchers have identified a number of structures and pathways in the brain that deliver rewards through stimulation. So neurons in the medial forebrain bundle are most susceptible to this stimulation. And neurons all along this pathway and especially those in the nucleus accumbens, secrete the neurotransmitter dopamine. And several competing hypotheses about the precise role of dopamine have emerged, including its link with the expectation of a reward and craving something. So either way, research provides supports for dopamine's role in the reward center. And here we see that behaviorists studying learning in rats found that if a rat found food in one arm of the maze on the first trial of the day, it typically ran down the other arm on the very next trial. And so this behooved behaviorists because, as we learn with operant conditioning, if we reinforce an organism such as a rat, then we would expect them to go back down that first arm of the maze and be reinforced again. But that was not happening, and that was not the case with rats. And so although this was puzzling for behaviorists at the time, this makes sense in an evolutionary perspective now that we know more about evolution and how that affects biological systems and also psychological processes. So rats are foragers, and like all foraging species, they have a highly adaptive strategy of finding food somewhere. So they either eat it or they store it, and then they look somewhere else for more food. So other studies involving training animals for movies, for example, learned that they could not train pigs or raccoons to drop coins in a box because they associated coins with food. So they treated coins as food. The pigs would root around in the dirt with the coins, and raccoons would wash the coins by rubbing the coin between their paws. So what we found from these observations in species, including humans, are biologically predisposed to learn some things more readily than others and to respond to stimuli in ways that are consistent with our evolutionary history. And another type of learning that's discussed in the chapter is observational learning. And so kind of straying away from classical conditioning, it is along the same lines, but it's really its own specific niche. So it's observational learning. This takes place by watching others, the actions of others. So Albert Bandura is known for investigating the parameters of observational learning, and we'll actually watch a video on his famous Bobo doll experiment in class. So he found that children who observed an aggressive adult playing aggressively with a Bobo doll were twice as likely to interact aggressively as opposed to children who did not observe an aggressive adult. So this was found as these children imitated novel and specific aggressive acts like hitting the doll with a mallet and throwing it in the air. And this suggested that these acts were a result of observational learning. It also showed that they were sensitive to consequences of actions that they observed. So if they saw the adult punished for their aggressive behavior, we saw a decrease in the aggression of children. But on the flip side, if they saw that the adults were being praised for their aggressive behavior, then their aggressive behavior would increase. So a good example of observational learning includes sports. So often someone can learn to play a sport by merely observing a skill without actually practicing it. So observational learning is well suited to seeding behaviors that can spread widely across a culture through a process called a diffusion chain. And a diffusion chain occurs when individuals initially learn a behavior by observing another individual, and then they serve as a model from which other individuals learn that behavior. So behaviors such as using a new tool can be spread accurately across 10 children. And so as a result, what this shows is that there are potentially powerful means of influencing others in our culture. And with this observational learning, there's a wide variety of species that actually learn by observing. So pigeons learn to peck at a feeder or step on a bar to get feed, has been shown in psychological studies. Monkeys who had never seen a snake were observed to develop fear of snakes by watching the fear reactions of other monkeys. Some researchers point to this quick learning due to the biological predisposition to fear snakes, and also that makes sense on an evolutionary perspective that they would be afraid of snakes. Also, we see monkeys who are raised in the wild can learn to use a tool to obtain food, but don't learn specifically how to use the tool after watching a child use or to model this type of behavior. However, monkeys that were raised in a more human-like environment demonstrate specific observational learning and even perform similarly to children using this novel tool. And so this may be explained by the enculturation hypothesis, where this hypothesis explains that being raised in a human culture has a profound effect on the cognitive abilities of chimpanzees, which in turn increases their observational learning capacities. So they have an ability, they essentially grow this ability to maybe have some higher order thinking, or just increases their ability to learn more from observation. So others criticize this hypothesis based on very little evidence, but more recent studies have demonstrated support of this hypothesis. So this hypothesis implies that cultural influences on cognitive processes really support observational learning. And neural elements of observational learning include mirror neurons, which not only fire when an animal performs an action, but when an animal watches someone else. And so this is more powerful if the observation is of the same species and performing the same task. And so as a result, mirror neurons play a critical role in the intentionality of behavior, as well as the prediction of future behavior. So it's also thought that mirror neurons are located in specific subregions in the frontal and parietal lobes, and there's evidence that individual subregions respond more strongly to observing certain kinds of actions. So when watching someone else perform a task, the some of the same brain regions are activated as when you're actually performing the task yourself. So this suggests that observational learning speeds up learning, and prevents potentially dangerous errors. And so if we see someone and they make an error in the task that they're completing, then by observing them, we may not make the same mistake as the person that we were watching. So this leads us to talking about implicit learning. And implicit learning is learning that takes place largely independent of our awareness on both the process and the products of information acquisition. So this is, again, implicit, having this this lack of awareness that we're even learning. So some forms of learning start out explicitly but become more implicit over time. So driving a car. So when you first begin, you're explicitly trying to learn where your foot goes on the gas and the brake and shifting gears, to years later where you automatically get in the car and you just drive. So this is similar to implicit and explicit learning. And one specific term that's related to this implicit learning that helps to explain this is habituation. So habituation is a simple case of implicit learning where this is the general process in which repeated or prolonged exposure to a stimulus results in a gradual reduction in responding. So people who live near train tracks habituate to the sound of the train whistles and they don't even notice it. And so this is a type of habituation. They get habituated to that sound of the train tracks. So implicit learning, even in humans, can occur without explicitly learning or trying to memorize something. So we can see this in children's books, and that's why we have a copy or a picture of How the Grinch Stole Christmas. So as children, we learn morals and values through books and stories such as How the Grinch Stole Christmas, even though we are listening to the storyline of the Grinch going down into Whoville and stealing all the presents. Really, there's this underlying moral and these different values that underlie the story that we actually learn and we gain from the book rather than only learning the storyline. And so with that, that wraps up the third section of Chapter 7.